empirical formula gives simple whole number ratio of different atoms present in a molecule or in a formula unit. It is calculated by using the mass or the percentage of different elements in a molecule. We're using following method to calculate empirical formula. For example, the first we find the mass of these combining element in grams, and then we calculate the mole by using the molar mass of these individual element. And then we find the simple whole number ratio by dividing the smallest value of these mole. For example, if we have the magnesium oxide, so magnesium react with oxygen and this produce magnesium oxide, this white fume that produced, and we can calculate its empirical formula. For example, the mass of magnesium is 0.24 gram, while oxygen is 0.16 gram. Their molar mass of these elements, the magnesium is 24 gram per mole, while oxygen is 16 gram per mole. We get it from periodic table. We're going to calculate their mole by dividing the mass of magnesium over its molar mass. So this value will be 0.01 mole, while oxygen will give us 0.01 mole. The both values are the same. So we're going to see the smallest value usually to divide these both values to get simple whole number ratio. For example, if you're going to divide any value from these, so that will give us a simple whole number ratio, 1:1. So the empirical formula of the magnesium oxide will be MgO because the both atoms are with a 1:1. We're going to see another example of silicon oxide. For example, the silicon is 47%. While the oxygen, we can calculate by the percentage of silicon, the 100 minus the 47, this will give us 53%. The first, we will convert this percentage into the gram. So we are representing 47% in 47 gram and oxygen 53% in 53 gram. Their molar mass in periodic table of silicon is 28 gram per mole, while oxygen is 16 gram per mole. We are going to use their mass over molar mass to calculate their mole. The smallest mole of silicon are 1.68 mole, while the oxygen is comparatively larger in number, 3.31 mole. We're going to use this smallest value of the silicon to divide these both values to get simple whole number ratio. And we got the silicon is 1 and oxygen is 2. So our empirical formula will be 1:2. We're going to see another example of phosphorus pentoxide. For example, the phosphorus is 44%, while oxygen is the 100 minus 44, this will give us 56%. So mostly in your question paper, the examiner can give you one element mass and you're supposed to calculate the second because the one sample of this compound is 100%. So here, the mass in gram of the phosphorus is 44 gram and oxygen is 56 gram. While their molar mass in periodic table of phosphorus is 31 gram, while oxygen is 16 gram per mole. We're going to divide this mass over molar mass to get number of mole of phosphorus and oxygen. And that is 1.4 mole of phosphorus, while oxygen is 3.5 mole. So here, we will find the smallest value. The smallest value of the phosphorus is 1.4 mole. We're going to divide this smallest value to the both value to get simple whole number ratio. Sometimes we are getting a very minor difference. For example, if there is a 1.97 or something, so we can ignore this very small difference and move to the upper value. But here, 2.5, there's a big difference between 2 and 3. So that's why we will multiply the number 2 and 3 and 4 until we got whole number ratio. For example, we're going to multiply by number 2. So we'll get the 2 of phosphorus while the oxygen is the 5. Now this is whole number ratio of oxygen and phosphorus. And we got 2:5 phosphorus pentoxide. This is our empirical formula. We can use this empirical formula and calculate the molecular formula. For example, if we are having another molecule that is a hydrocarbon organic molecule, and this hydrocarbon consists of the only carbon and hydrogen. Now the percentage of a carbon is 85.7%. And with the reference of this carbon, we can calculate the percentage of hydrogen. 100 minus 85.7, this will give us 14.3%. We're going to represent this percentage into the gram, and this carbon will be 85.7 gram, while hydrogen is 14.3 gram. While their molar mass in periodic table of carbon is 12 gram, while hydrogen is 1 gram. We're going to find their molar mass, we're going to find their moles by dividing the mass over molar mass. So the mole of carbon is 7.14, while hydrogen is the 14.3. Here, smallest value is 7.14. We're going to divide this value to the both values and get simple whole number ratio. This is carbon 1 and hydrogen 2. So mean in this hydrocarbon, the carbon and hydrogen are coming with a ratio 1:2. So their empirical formula will become CH2. We're going to calculate the molecular formula with a reference of empirical formula. For example, if we have the empirical formula, so we're going to follow the following method to calculate the molecular formula. Before that, we're going to define the molecular formula, so which give us actual number of atoms present in a molecule, while the empirical formula give us the simple whole number ratio. So here, the first we calculate empirical formula, and then we got the empirical formula mass by using the empirical formula. Then we find the relative molecular mass of the molecular formula with the help of actual experiment. So that's why this value of relative formula mass of molecular formula will be given in the question. Then we divide the molecular formula mass by the empirical formula mass to get n number. And this n number value, we multiply to the value of empirical formula to get molecular formula. For example, if we have a phosphorus with an empirical formula is P2O5, while their empirical formula mass will be the phosphorus in periodic table is 31, we're going to multiply with 2, plus oxygen is 16, we're going to multiply with 5, and this will give us 142. This is our empirical formula mass. While the relative molecular mass will be given in the question paper because we calculate in actual experiment, and this is 284 gram per mole. We're going to divide the relative molecular mass by empirical formula mass, and this will give us the value 2 is n, and n number is 2. Now this n number 2, we multiply with the given value. 2 multiply 2, this will give us 4, and 2 multiply 5, that will give us 10. So the ratio of the phosphorus and oxygen is 4:10. So this will give us the molecular formula of the phosphorus pentoxide, that is P4O10. We're going to see that another example where there's a unknown organic compound elements are present. For example, unknown mean their actual number is unknown. So for example, if there is a compound X contain carbon, hydrogen, and oxygen, So where their actual number is unknown, so with the reference of their percentage, we can calculate their empirical formula. For example, 54.54% is carbon, 9.09% is hydrogen, while the mass of oxygen is 36.37%. Now here, so these are percentage are present by mass, and we're going to use these percentages, for example, the carbon, hydrogen, and oxygen, and we represent their percentage by the gram. For example, the mass in gram of carbon is 54.54 gram, and hydrogen is 9.09 gram, and oxygen is 36.37 gram. While the molar mass in periodic table of carbon, hydrogen, and oxygen, these are given value. We're going to use their mass over molar mass to get the mole of each element. Now we will find the smallest value in these mole. The smallest value is 2.27 mole of oxygen. We're going to use this smallest value to all these given value to get simple whole number ratio. For example, the carbon we got 2 and hydrogen is 4 and oxygen is 1. So we got the empirical formula of C2H4O1. So this molecule, we have an organic molecule, so that's our ethylene oxide. We're going to use this empirical formula mass value to get the molecular formula. For example, we have ethylene oxide, C2H4O, and the compound X has a relative molecular mass that is 88 gram, which is calculated by actual experiment. So we are going to find the molecular formula of this compound, this molecule. For example, let's suppose we have empirical formula of ethylene oxide is C2H4O, while empirical formula mass is 44 gram. While the molecular formula mass is given in the question, that is 88 gram per mole. So we're going to divide the relative molecular mass divided by empirical formula mass, and this will give us 2. So this 2 n number, we're going to multiply to the empirical formula value. So this will give us 2 multiplied 2, this will give us 4, and 4 multiplied 2, that is 8, and 2. So this will give us the value C4H8O2. So this is the molecular formula from the empirical formula. So here we got the idea how we can calculate the empirical formula and the molecular formula. If you have further query, you can put in the comment box. So hopefully it will be helpful for you. Thank you.